So what Waymap offer is independent access and navigation. We need to be able to give people great instructions so that they can explore or navigate an environment easily and simply. What we build our technology on, though, is just good old-fashioned indoor location. And that's just hard to do. And this is really where Waymap sets itself apart. Our technology, because it's based on dead reckoning and following people around as they move around a known map, we don't need to install any beacons, we don't need to know about Wi-Fi. The only infrastructure you need is your mobile phone. So what is pedestrian dead reckoning? Pedestrian reckoning is actually, at one level, really simple. You're just following someone as they walk, but actually really complex, because what you've got to do is you've got to get rid of all of that error. What we've got is we've got a mechanism that does pedestrian dead reckoning by using probability. You take all of the sensor data, whether it be accelerometers in terms of your linear acceleration or your rotational acceleration, so your gyros, your magnetometer, which is basically your compass, which will mostly lie to you in an indoor environment. And then you add to it the things like barometers for changing levels. So all of that sensor data is coming in, and we then estimate how you are moving by using an approach which fuses all that data together and then matches that to a map. So pedestrian dead reckoning is a combination of taking your movement as you walk, every step and every direction, and then you match it to the map in order to filter out those steps which you know are not true. And in that way, working together, what you can do is you can remove some of the compound errors that grow. Underneath the pedestrian dead reckoning, we have a mechanism for working out exactly how each step moves as part of the map matching. We use what's called a particle filter. The particle filter samples where you might be with a number of particles. So we use thousands of particles. Each one is a potential place, a candidate for where you might be every time you take a step. And that information is fused together using probability theory. And so it is, if you take a step that is through a wall, that's very improbable. And then what we do is we analyze all of the thousands of particles, we analyze them all to work out where the densest cluster around the highest probability is. And we pick one that says that's actually the most likely location for that person to be. Our app is about building confidence. We are driven by our user experience first, and our technology is the enabler for that second. And we talk about being hands-free and heads-up. Now, hands-free means I don't want to have the phone in my hand. Heads-up means I want to be able to just be like a normal human being, interact with other people, interact with the environment around me. Now, one of the other technologies that we can often compare ourselves to and get compared to is augmented reality. Using image recognition to be able to pinpoint where you are in order to be able to deliver that sort of navigation experience. We are really excited by AI and augmented reality, the ability to pick an object and describe an object for that last centimetre. That is really powerful, but that is not the right technology for getting someone around hands-free heads-up. What you need is a technology that is really simple, that will work in any environment with just a map. And then that once you've got to the right locations, you're within that last metre. Providing image recognition is really powerful for that last centimetre.